to technologies and capabilities that have shaped our culture.
The breakthroughs of the Artemis era will define our generation and the generations to follow.
The tens of thousands of jobs associated with propelling us to the moon today, lunar economy, that will see hundreds of thousands of new jobs develop around the world.
Shared effort.
Because the missions of tomorrow.
Because the ambition to go has already begun.
And because Mars is calling. We need to learn what it takes to establish a community on another cosmic shore. So let's camp close before pushing out.
And so, we go to the moon now, not as a series of isolated missions, but to build a community on and around the moon capable of proving how to live on other worlds.
For more than 50 years of peaceful exploration to send a new generation to the lunar surface to stay.
We went to the South Pole to establish the Artemis Base Camp.
Exploration of the lunar surface.
To assemble a complex ship in deep space.
Descending down to and returning from a distant surface.
With improved spacesuit designs, mobile habitats, and relocated supplies.
Resources we find on these other worlds. Starting with finding water ice and purifying it to drinkable water.
And oxygen to breathe.
We will establish fission power plants on the surface of the moon, capable of supporting a growing community of efforts.
Fuel deep space outposts.
None of this is simple or easy, but nothing in our history ever has been.
The Eagle has landed. We got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
This kind of continuous lunar presence is a natural extension of all that we've learned in low Earth orbit. And what we will accomplish there will ensure the monumental missions to Mars are within reach. As we ready the launch of the first Artemis mission, and as commercial companies ready their lunar landers for the first private payload deliveries?
There is one thing that explorers all throughout time have had in common. They're all at the mercy of the weather. And while things like rain, wind, and lightning all factor in, you can't forget about radiation. The astronauts and the systems of their future space vehicles will have to be protected from deep space radiation. And that's why today's scientists are working hard to improve our ability to accurately forecast dangerous space weather.
The space we travel through. Seafaring nations began to explore new regions of the world. One of their biggest concerns in making the journey safely was how to cope with weather. They could harness the wind for power. They could rely on the sun and the stars for navigation. They could build sturdy ships. But if a storm rose suddenly, they were at nature's mercy. More than 5 centuries later, our nation is once again on the cusp of exploring new worlds. And once again, one of our concerns about traveling long distances is the weather, space weather. While space is a vacuum, it's not 100% empty. Particles, energy, and magnetic fields travel through the void. Much of these emanate from the sun's corona, as part of a constant outward flow known as the solar wind, which stretches well beyond the orbit of Neptune. There are also high-energy particles or cosmic rays in the mix, which travel vast distances from dying stars or supernovae. Earth's magnetic field and relatively thick atmosphere act as a shield against the most harmful forms of this radiation, but in space, there is no such deterrent. If we want to travel through this space, we need ways to protect our astronauts. These particles can affect our technology, tripping onboard electronics. Dr. Yari Calatavega, space weather scientist at NASA's Goddard Space Flight Center, notes, "We are working hard to forecast when these particles will be at their peak, such as during solar flares or coronal mass ejections. Acute exposure to these solar energetic particles is a serious concern for astronauts and instruments. Therefore, having a better understanding of when to expect solar activity is important for safely sending our astronauts and spacecraft through space. Ironically, such space weather activity can actually protect against another threat to astronauts. The sun's activity can block dangerous cosmic rays coming from other stars, which are constantly present, illustrating the complexity of the system NASA tries to understand and mitigate for our space travelers. Over time, sea captains learned when to sail their ships and when to stay in harbor, based on their accumulated knowledge of the weather. It's more risky to be on the water in the Caribbean during hurricane season, and you'd want to consider avoiding the northeast coast of America during the height of winter. Dr. Collada Vega says, it's very similar to what we're doing today. We're constantly developing and testing new models to predict space weather, and we're constantly seeking new data to refine those models. A host of heliophysics missions observe space like terrestrial weather sensors, which work in tandem to paint a bigger picture of our space environment. In August 2018, NASA launched the Parker Solar Probe to help us better understand the sun's activity, especially what drives the solar wind and how energetic particles get accelerated. This data could be used to improve models of space weather forecasting, ultimately helping us find new and better ways to shield our spacecraft and protect our astronauts. Whether it was the oceans ancient ships traveled through, or the space we will one day travel through, we know this: keeping a watchful eye on the environment around us